everyone, welcome to my channel. In this video I will demonstrate how to implement two different and two important graph transversal algorithms in Python, which are BFS and DFS. So BFS means breadth first search and depth first search, DFS. And I will also apply these algorithms on three different scenarios to show how graph transversal works in real situation. So if we make overview on BFS and DFS. So first we'll talk about BFS. So it is basically explores a graph level by level starting from a given. It uses a QE data structure which follows the first in first out principle. So this means the first node added to the QE will be the first one explored. I will tell you in the code if you don't understand and let me know. And as well as DFS, instead of exploring level by level, DFS goes as deep as possible in one path before backtracking. DFS usually uses recursion or a stack to keep track of nodes during transversal. So if we move to the code, we will see some of the graphs. So in this program I created three different graph scenarios, and I will show you also which are this. So I want to explain this one by one and tell you what is going on in this situation. So let's get started. So the very first line from collections import decoy, this is basically the module we have applied. Collections is a Python module that provides special data structures, and decoy means double-ended queue. Okay, and we have also BFS requires. Why we have done it? Because QE requires a BFS, means BFS requires a QE, and deQE allows fast insertion and removal of both ends of node, you can say. So define BFS. First we define a function BFS graph. Graph means the graph structure and start means the starting node of the parameter. And we have applied two parameters, graph and start. So visited set equal to and QE deQE result equal to, this means that visited means keeps track of nodes already explored. Okay, and QE stores nodes waiting to be visited, that the nodes that are not visited are waited in this queue, and the result records the transversal order which one by one they are visited. Another end, while QE is means this loop continues. We have added a while loop which continues until the queue becomes empty. It ensures BFS keeps exploring nodes until all reachable nodes are visited. Okay, so if node not in visited dot node result in append. So this means, sorry, we have missed the queue dot pop left. This is basically remove the first element in the queue. BFS follows first in first out order. This means the first node P, if you can say 1 2 3 4, 1 is the node starting node, 1 will be pop left, and 2 3 4 will be in the result. Understand? So we can also we can run the process, but firstly we can see the code. Now if node in visited, this this prevents revisiting the same node multiple times. That if node is not visited, then it will go again to that node, because we have applied the while loop, while queue. Now visited dot add node result dot append node. The node is added to the visited set. Okay, and result dot append, it is also added to the result list to record transversal order. Visited add the node which is visit, and the result, that is the transversal order of the node. Similarly, for neighbor in graph, this loop goes through all adjacent nodes connecting to the current node. Okay, means A is connected to B, C, and D. So A is connected. A neighbors of A are B, C, and D. If we take as an example, we'll apply return list and of this BFS. The BFS code has done. Now we have come through the DFS. Now DFS is same as BFS, but it is changed in some occasions. So we have also defined DFS function. It also accepts visited result tracks, visited node, stored transversal. It is the same. But if we move to if visited is none, visited set, if result is none, result set. This is basically means when DFS starts for the first time, these variables are initialized. Okay, these variables are starting point. So visited.add start, result.append start. The starting node is marked as visited. Okay, and the result.append it is added to the transversal result. This means that the starting node is 1 and they are connected to 2, 3, 4. So the starting node is 1 and it is visited to 2, 3, 4 because they all are connected. Okay, in some cases it is different. So for neighbor in graph set, this loops all nodes connected to the current node. Okay, if node not in visited, DFS graph neighbor, this means if the neighbor is not visited, DFS calls itself recursively. It will repeat itself. This allows DFS to go deep into the graph before returning. DFS graph neighbor visited result. This means that DFS to go deep into the graph before returning, that it will visit deeply to the neighbors nodes and then return to its starting point. And return list after transversal is completed, DFS returned the visited node order. As I said that it returned to its original node. So I have this is the three scenarios I have made. You can see. So in this adjacency list representation I have made. This is means A is connected to B C D, B is connected to E F, C connected to G, D connected to H, and so on. You can see. So scenario 1, this line is called BFS and DFS functions, and the transversal starts from node A. Graph 1 A graph. This means that it is starting from A. Similarly, scenario 2, it is also the same. BFS starting node is B in both cases, and as well as scenario 3, computer network. Now, this is the DFS and BFS code we have studied. If we run this code, you can see this is the output we have got. BFS A, B, C, D, E, F, and DFS. DFS, I have told you before that it is basically the last in, first out. We have discovered the scenario of it goes deep as possible in one path before backtracking. Okay, so A is connected to B and B, E, F. See, it is going further apart deep into the neighbors and then back to the given point E, F. As well as the scenario 2, BFS, it is the sequence of the nodes, sequence of traveling P, Q, then RS, TU, VW. But in DFS, it is different case. P, Q, S, deep into the S, and then V. So it is going deep into the nodes and then returning to its original node. So this is the BFS and DFS code. Hope you understand this code. If you not, comment on my YouTube channel if any queries. So this is all we have done. Thank you so much for listening this, and Allah Hafiz.